So this is the second class of Newton's laws of motion. Okay. So Newton's third law. So what is Newton's third law? So the definition is for every action, there is an equal and opposite reaction, equal and opposite reaction. For every action, there is an equal and opposite reaction is called Newton's third law. So what is the example? Example is aeroplane. Okay. So this is about the Newton's third. Now next topic, very important for 5 marks. Conservation of linear momentum. Conservation of linear momentum. This is important for 5 marks. Conservation of linear momentum. So what is the definition for the conservation of linear momentum? When no external force acting on the body, when no external force acting on the body, the algebraic sum of moments, the algebraic means addition, algebraic sum of linear momentums is always remains constant, then that is called as conservation of linear momentum. Okay. So here consider two bodies of masses named as M1, another body of mass M2. This I am naming as A and I am naming as B. It is moving with initial velocity u1 and it is moving with the initial velocity u2. Okay. Consider two bodies of mass m1, m2 and they are moving with initial velocities u1 and u2. Okay. u1 initial velocity is greater than the initial velocity u1 is greater than. Now this is when they are moving, we can say that it is before collision. Now when they are moving, at some point two bodies will be colliding. Why? Because initial velocity u1 is greater than u2. So here this I am naming as A and this is we are naming as B. So here what I am writing as during collision. So when they collide, what we will write? This we will write as force on A due to B. Okay. This what we will write as force on B due to A during collision. And after again they move with final velocities. This is A, mass m1 and this is the mass m2. This is B, this is B1 and this is B2. So here consecutive bodies of masses m1, m2, and they are moving with initial velocities u1 and u2. u1 is greater than u2, so this is before collision. When u1 is greater than u2, what happens? It collides at some point. So what I'm doing? This is, if it comes like this, force on A exerted on B. If it comes like this, force on B exerted on A. And after that, what happens? After collision, again it is moving. So after collision also it is moving with final velocities. After collision, they are moving with final velocities. m1, m2 with final velocities as v1 and v2. Okay. Now, the total momentum of the body, before collision, what is the value? Total momentum of the body before collision. Total momentum of the body before collision is given by, what I should write? This is m1 u1 plus m2 u2. Next, total momentum of the body after collision. What we are writing for this one? After collision, this one m1 v1 plus m2 v2, m1 v1 plus m2 v2. Now, what is the change in the momentum? So here, change in the momentum for body A, what we should write? So change in the momentum for body A before collision as well as after collision. So this is m1 v1 and this one for A minus m1 u1. Next, same thing, change in the momentum for body B, what we are writing? This is m2 v2 minus m2 u2. Okay. Now, according to Newton's third law, for every action there is an equal and opposite reaction. So what we have studied here, one figure we have drawn like this. When collision occurs, this A, this B, so force on A, B, and this is written as force on B exerted by A. So here what I am writing as Newton's third law, for every action there is an equal and opposite reaction. So for this one, what I am writing as FAB is equal to minus, for every action equal and opposite reaction, FBA. Okay, so here what happens for this A, this is the mass m1, this is the mass m2. So what I should write it? Force means m into A. So here, since what I should write, F is equal to m into A. Now, for the force on AB, m into A means m1, this is m1. Acceleration means change in velocity v1 minus v1 divided by t. Acceleration means what? Change in velocity, final minus initial divided by t. This is some form. So here is equal to minus FBA. FBA means what? m2 into v2 minus u2 divided by t. Okay. Now this t and this t is cancelled. From here, what is the value? m1 v1 minus m1 u1 is equal to minus m2 v2 minus into minus is plus m2 u2. From here, what I should write? m1 v1 plus m2 v2 is equal to minus m1 v1. If it comes here, what I should write? m1 u1 plus m2 u2. Therefore, we can say that total momentum before collision is equal to after collision, means always it remains constant. So this is about the conservation of linear momentum. So it is important for 5 marks exam. Next concept, equilibrium of a particle. Equilibrium of a particle. Listen, equilibrium of a particle. This is the surface. We are considering a particle at point O. Okay. Here there are three types of forces. This I am naming as F1 and this I am naming as F2 and this I am naming as F3. Okay. Now this F2 is divided into two components. One is the horizontal component and then is the vertical component. So this one I am assuming as alpha. So whenever angle theta, angle alpha touching, this we can write as F2 cos alpha. Okay. Angle not touching is F2 sin alpha. Similarly, this F1 is divided into two components. One is the horizontal component and there is a vertical component. So this one we are assuming as beta. So from here, what I should write? Angle beta touching is F1 cos beta and this one we can write as F1 sin beta. Okay. Now at equilibrium, what we can write it here? Forward minus backward. So from here we can write as F2 cos alpha minus F1 cos beta is equal to 0. From here we can write as F2 cos alpha is equal to F1 cos beta. Okay. Next, another one. Here what we can write it? F2 sin alpha plus F1 sin beta. This is upward minus downward is minus F3 is equal to 0. From here we can write as F2 sin alpha plus F1 sin beta is equal to F3. So this is the equilibrium of a particle. Equilibrium of particle. Next concept, expression for acceleration expression for acceleration for at goods machine, at goods machine, very important for 5 marks. Okay, so in the first class I said tension. Okay, now for this one, this is the rigid support. This is the rigid support. Now what I am doing is I am considering a pulley, nothing but V. For this V, I am attaching the thread, nothing but string. Okay. Now I am giving the mass named as M1, and here I am giving the mass M2. Okay. Now this is a string, this is a string. This consists of two masses M1, M2, and here M2 is greater than M1. So what is the meaning of this one? M2 mass is greater than the mass M1. Okay. Now here, how to take the equation? When M2 is moving downside, so this is acting under the acceleration due to gravity M2g. Okay. So when it is moving downside, where is the tension acting? So the tension is acting on the upside. So when it is moving downside, acceleration is downwards. Acceleration is downwards. Next, in the similar way here, what happens? This is acting under the acceleration due to gravity, and here also the tension is acting upward. Okay. Next, here it is moving upside. This is big weight, this is the smaller weight. Therefore, what happens? When it is moving up, acceleration is g. Then how to take the equations? Now here, for the mass M2, what I should write? Acceleration is downwards. Downwards means we have to take this one. So what is the value? M2g minus tension T is equal to M2 into A. M2 into A, this is named as equation 1. Otherwise, okay. Now this value we can write as M2g minus M2A is equal to T. This is named as equation 1. Okay. Now in this one, acceleration is moving upward. Therefore, we should consider T first. T. Next, this one minus M1g is equal to M1 into A. So this is nothing but M1 into A. Okay. From here, what is the value? T is equal to M1g plus M1 into A. Okay. So this is the equation. So this is the tension, this is also tension. So the question is expression for acceleration. Acceleration is represented by A. Okay, we have to find out the acceleration A. Then how to do it? So now what are we doing? By equating 1 and 2. By equating 1 and 2. So what I should write? This T is equal to, what I should write? M2g minus M2A is equal to tension M1g plus M1A. Okay. Now here what happens? M1g, if it comes here, so what is the value you should write? M2g minus M1g is equal to minus M2A. If it comes here, what I should write? M2A plus M1A. The question is acceleration we have to find out. Therefore, we have to take the common A. So, what is the value you should write here? Okay. Now, what is the value? M2 minus M1 into G is equal to, what I should write? M2 plus M1 into A. So, what is the acceleration? A is equal to M2 minus M1 into G. divided by m2 plus m1. So this is the acceleration. So this is the acceleration at Wood's machine. Next concept, apparent weight of a person, weight of a person in a moving lift. This is also very, very important for pilots. Apparent weight of a person in a moving lift. So here, suppose a person is standing in the lift. Person is standing in the lift. In the lift. Okay. So there are different types of cases. Okay. So suppose a person is standing in the lift and G be the acceleration due to gravity. G be the acceleration due to gravity. G be the acceleration due to gravity. So, first, what is the case 1? When lift is stationary, then what happens? When the lift is stationary, what happens? So here this is a lift. Okay, a person is standing in the lift. So this is acting under the acceleration due to gravity. And so I said normal reaction in the previous class. Normal reaction is can be written as from here to here. This can be written as R, or we can